In the previous video, we took this fraction here and we split it apart into two fractions. And we solved for a and b using a process of selecting values for x to plug into the equation and then solving for a and b. This video I want to solve the same thing, so I'll get the same answer as last time, but I want to do it in a different way. Each person has their own preference as to which way they like better. I will present them both. I know that when I was learning this myself, the way that I almost always did it was the way I'm about to show you, but now I more often do it the other way. My preference has changed over time. Anyway, we're still going to do the same thing. We're going to figure out what a and b are. So I'm going to multiply both sides by this denominator. So if I multiply the left-hand side here by the denominator, I end up with just the numerator. And then the denominator times the first fraction, the x minus 3's cancel out, so I've got a times x plus 1. And then likewise, the denominator times the second fraction, the x plus 1's cancel out, and I've got b times x minus 3. Okay. What I'm going to do now is I'm going to multiply this thing out and then collect some like terms. So this is ax plus a plus bx minus 3b. Now I'm going to collect the terms that have x's in them. So there's an a plus b times x. So from this term right here and that term right there, I factored out an x. And then I've got a constant of a and another constant of negative 3b. So on both sides of this equal sign, I have linear functions in x. I have x to the first power times a constant plus another constant. X to the first power times a constant plus another constant. The only way that this linear function here could equal that linear function there is if the corresponding coefficients are the same. So for instance, on the right-hand side, no, this would be the left-hand side, the coefficient in front of the x is a 3. That has to equal the coefficient in front of the x on the other side. So a plus b has to equal 3. Likewise, the constant coefficient here of negative 1 has to equal the constant coefficient over there, which is a minus 3b. So what I end up with here is two equations in two variables. And I need to solve them simultaneously. So what I'm going to do is I'm going to do this by elimination. So what I'm going to do is I'm going to multiply the bottom one by negative 1. So this will become a plus sign. That'll become a minus. This will become a plus. And now I'll add the two equations together. So 3 plus 1 is 4. And on this side, the a plus minus a is 0. And the b plus 3b is 4b. So I need 4 to equal 4b. And that tells me that b is equal to 1. Which is what I got last time. Okay. Likewise, with b equals 1, I can now substitute it back into either one of those, but I think it's easiest just to do the first one here. That 3 has to equal a plus 1, so that tells me that a has to equal 2. So the fractions that I end up with are, up here, a over x minus 3, so that would be 2 over x minus 3, plus b over x plus 1, and the b is 1, so that would be 1 over x plus 1. Either way is fine. You plug in values of x to get various equations with a and b in it, or you multiply everything out and then you collect like terms. You'll have match the coefficients on the left side with the coefficients on the right side.